In this video, we will discuss volume of solids in which we will try to understand how to find volumes of cuboid, cube and right circular cylinder, and we will also discuss some representative problems based on this concept. Hello friends, welcome to my YouTube channel Number Collage. My channel features easy to understand concept videos on mathematics. I believe the best way to learn math is to understand mathematical concepts through basics. So let's learn math through basics. In this video, we are going to talk about volume of solids. Volume of a solid is the amount of space or region occupied within its boundaries. Volume is also the capacity of a solid to hold a liquid or a gas within its boundaries. The first solid that we are going to talk about is a cuboid. It has three important dimensions: length, breadth, and height. The product of length and breadth gives us the area of the bottom surface, and if we multiply this area of the bottom surface by the height, we get volume of cuboid. So we will write volume V of cuboid as area of the bottom rectangle, which is LB, multiplied by the height of the cuboid h. So V equals LBH is the volume of this cuboid. It is also the capacity of this solid to hold a liquid or a gas within its boundaries. If we fill this cuboid with water, then the amount of water that it can store also tells us its volume. The next solid that we will talk about is a cube. Cube has all six surfaces square. So length of its edge P L, length of this edge P L, and height is L. The volume of cube is also area of the bottom square, which will be L square multiplied by its height, which is also L. So therefore volume of cube V can be given as area of bottom square, which will be L multiplied by L multiplied by the height of the cube, which will be L again. So therefore volume of a cube will become length of its edge cube, or L cube. The third solid that we are going to talk about is a right circular cylinder. Its volume will be equal to the area of its bottom circular region, whose radius equals r, and the height of this cylinder is h. So its volume V will be equal to area of the bottom circle, which is pi r square, multiplied by height of this cylinder, which is h. So the volume of this right circular cylinder is pi r square h. This volume also is the amount of liquid or gas that this right circular cylinder can hold within its boundaries. Since in the formulas or formulae of these solids, product of three dimensions are involved: length, breadth, height, length, radius, and height. The unit of volume of a solid is always unit cube or cubic units. Let us find volume of this cuboid, whose length is 8 centimeter, breadth is 3 centimeter, and height is 2 centimeter. The volume of this cuboid V is L into B into H. So that will be 8 multiplied by 3 multiplied by 2, which will be 48. Since the unit is centimeter, the volume of this cuboid will be 48 cubic centimeters. Now let us find volume of this cuboid. The area of its bottom surface is 24 meter square and its height is 3 centimeter. So volume of this cuboid will be area of the bottom rectangle A multiplied by its height h. Now the area is given in meter square, so we write area A as 24 multiplied by the height h is in centimeter, so we have to convert it in meter, so we will divide this 3 by 100, so that gives us 24 threes are 72 upon 100. So the volume of this cube will be 0.72 meter cube or cubic meter. Let us find volume of this right circular cylinder whose length is 10 centimeter and radius of its circular surface is 7 centimeter. We know that volume of right circular cylinder is area of the circular surface, which is pi r square multiplied by height, which is 10 centimeter. So we write 22 upon 7 multiplied by r is 7 multiplied by 7 multiplied by 10. So this 7 gets cancelled and it will be 22 sevens are 154 and this 0, so that will be 1540 cm cube or cubic centimeter. So volume of this right circular cylinder is 1540 cm cube. Next, let us find volume of this right circular cylinder whose area of the circular surface is 250 meter square and whose height is 2 meter. So its volume will be area A of the circular surface multiplied by the height of the cylinder. So it will be 250, which is area A multiplied by height, which is 2 meter. So that will be 500 meter cube or cubic meter. So that will be the volume of this right circular cylinder. Now let us understand basics about unit conversion. We know that 1 meter equals 100 centimeter. So 1 meter multiplied by 1 meter will be equal to 100 centimeter multiplied by 100 centimeter. So 1 meter square will be 100 multiplied by 100, that is 10,000 cm square. Conversely, we can say that 1 cm square equals 1 upon 10,000 meter square. So therefore, whenever we are converting meter square into centimeter square, we have to multiply meter square by 10,000 to get meter square into centimeter square. And whenever we want to convert centimeter square into meter square, we have to divide by 10,000 to get centimeter square into meter square. For example, 25 meter square will be equal to 25 multiplied by 10,000, that will be 2,50,000 cm square. Conversely, 25 cm square will be equal to 25 divided by 10,000 meter square, which will be 0.0025 meter square. In the unit conversion of volume, let us consider 10 centimeter by 10 centimeter by 10 centimeter equals 1000 cm cube, which is exactly 1 liter. So therefore, we have 1 liter equals 1000 cm cube. So therefore, to convert liter to cm cube, we have to multiply the liters by 1000 to get liters into cm cube. Conversely, if we want to convert cm cube into liters, we have to divide this cm cube by 1000 to get volume in, for example, 30 liters will be equal to 30 multiplied by 1000, that is 30,000 cm cube, and conversely 30 cm cube will be equal to 30 upon 1000 liters. These 0 get cancelled, so that will be 0.03 liter. We know that 1 meter equals 100 centimeter. Therefore, 1 meter multiplied by 1 meter multiplied by 1 meter will be equal to 100 centimeter multiplied by 100 centimeter multiplied by 100 centimeter. So that will be 10 lakh centimeter cube. So therefore, 1 meter cube is equal to 10 lakh centimeter cube. But if we divide this 10 lakh centimeter cube by 1000, so we get 1 meter cube equals 10 lakh upon 1000. This will be liters. So these three zeros cancel with these three zeros, and what we get is 1 meter cube equals 1000 liter. Conversely, 1 liter equals 1 upon 1000 meter cube. So therefore, if we want to convert meter cube into liter, then we have to multiply this meter cube by 1000 to get the answer in liter. And conversely, if we want to convert liter into meter cube, then we have to divide liters by 1000 to get the answer in meter cube. For example, 15 meter cube will be equal to 15 multiplied by 1000 liter, that is 15,000 liter. And conversely, 15 liter will be equal to 15 divided by 1000 meter cube, that will be 0.015 meter cube. So this is how the unit conversions are done. Let us solve a few problems based on volume. The first among them is a cylindrical tank is given. In which of the following situations you will find surface area, and in which situation you will find volume? The first question is to find how much it can hold. Now, the words "it can hold" suggest that here we will have to find volume, because we have seen volume of a solid or a cylindrical tank is its capacity. That the second question is number of cement bags required to plaster it. Now the word "to plaster it" suggests that here we have to find the surface area, because after plastering is done, the cement in the cement bags is going to spread along the surface of the walls. Therefore, we have to consider the surface area in this case. Third question is to find the number of smaller tanks that can be filled with water from it. Now, the word "filled" suggests that in this case we have to find the volume of water, because we have seen volume is nothing but the space or region occupied by the solid, in this case the cylindrical tank. Next question is find the height of a cuboid whose base area is 180 cm square and volume is 900 cm cube. Suppose the cuboid in the question is this cuboid whose base area is given as 180 cm square. Let us name it A, and volume of this cuboid is 900 cm cube. Let's name is V. Now we have volume of cuboid V equals L B H. Out of these L and B, which means suppose this is the length of the cuboid and this is its breadth B, then LB denotes the base area of this cuboid. So we can write it further as base area multiplied by H. Now the volume V is given as 900 cm cube, which equals this base area, which is given to be 180 multiplied by height h of the cuboid. So that gives us height of cuboid h equals 900 upon 180. This 0 gets cancelled and we have 18 ones are 18 fives are 90. So that gives us height of the cuboid 5 centimeter. Next problem is a cuboid is of dimensions 60 centimeter by 54 centimeter by 30 centimeter. How many small cubes with side 6 centimeter can be placed in the given cuboid? Now this is the big cuboid of length 60 centimeter, of breadth 54 centimeter, and of height h 30 centimeter. We have to place small cubes of side 6 centimeter each within this cuboid, and we have to find how many small cubes of this size with side 6 centimeter can be placed in the given cuboid. So we will write like this: number of small cubes multiplied by volume of small cube equal to volume of big cuboid, that is n multiplied by small v is equal to capital V. So n will be equal to capital V upon small v. Now capital V is the volume of the cuboid, which will be length into breadth into height on small v will be 6 multiplied by 6 multiplied by 6. That is the volume of the cube. Now here 6 ones are 6, 6 tens are 60, 6 ones are 6, 6 nines are 24, 6 ones are 6, 6 fives are 30. So it will be 9 fives are 45, 45 into 10, that is 450. The number of small cubes that can be placed within the boundary of the big cuboid will be 450. Next problem is a milk tank is in the form of a cylinder whose radius is 1.5 meter and length 7 meter. Find the quantity of milk in liters that can be stored in the tank. Let us show the milk tank in the form of a cylinder whose radius is 1.5 meter. So the radius of this milk tank is 1.5 meter and length is 7 meter. So length of the tank is 7 meter. So this is L and this is R. We have to find the quantity of milk in liters that can be stored in the tank. We have to find the capacity of the tank, which is cylindrical in shape. So capacity is nothing but the volume. So capacity V of the cylindrical tank is volume of cylinder, which is pi r square multiplied by h, which in this case is L. So that will be 22 by 7, which is pi, multiplied by radius square, that is 1.5. This 1.5 we will write as 3 by 2. So here we put 3 by 2 multiplied by 3 by 2 multiplied by length of the tank is 7. So this 7 cancels with this 7. Then 2 ones are 2 elevens are 22. So that will be 9 multiplied by 11, that is 99 by 2, which will be 99 by 2 meter cube. We have to convert this into liters. So we will multiply 99 by 2 by 1000, because we know that 1 meter cube is 1000 liters. So that will be 2 ones are 2 fives are 10, 0 0. So the quantity of milk that can be stored in the tank is its capacity, which is 49,500 liter. Next question. If each edge of a cube is doubled, number one, how many times will its surface area increase? Number two, how many times will its volume increase? So let the cube in question is this, whose edge is L, so that when its edge is L, its surface area will be S equals 6 times L square. This is we have seen earlier. Now, according to this first question, if this edge is doubled, that means when it is made 2L, the new surface area, let's denote it by S new, will be equal to 6 times. Now here in place of L, we will put this 2L. So it will be 2L square. So that will be 6 times 4L square. We write it as this 4 times this 6L square. But this 6L square is nothing but S. So we will put 4 times S. The new surface area when the edge is doubled will be 4 times the original surface area. In the next question, how many times will its volume increase? So we know that volume of a cube is given as L cube, where L is the length of its edge. Now when the edge is doubled, the new volume will be 2L whole cube. Here in place of L we have put 2L, that will be 8L cube. But this L cube is nothing but V, so it will be 8 times V, which implies the new volume of the cube when its age is doubled will be 8 times its original volume. Next question is, water is pouring into a cuboidal reservoir, which is this reservoir, cuboidal in shape, at the rate 60 liters per minute. If the volume of reservoir is 108 meter cube, find the number of hours it will take to fill the reservoir. Now the water is pouring into the tank at the rate 60 liters per minute, which means that in 1 minute 60 liters is poured into the tank. So in 60 minutes, that is in 1 hour, X liters will pour in the tank. So let's take the ratios. So it will be 1 upon 60 equals 60 upon X. So that gives us, by cross multiplication, X equals 60 multiplied by 60, that will be 3600 liters. So in 1 hour 3600 liters of water is poured into the tank. Now the volume of the reservoir is 108 meter cube. So the capacity V of this reservoir is 108 meter cube, which will be 108 multiplied by 1000 liters. Since we have to find the number of hours it will take to fill the reservoir, we will argue like this. To pour 3600 liters into the reservoir, the time required is 1 hour. So therefore, to pour 108,000 liters, the time required, we have to find out. Let the time be y. Now taking the ratios of the quantities, we write 3600 upon 108,000 equals 1 upon y. These two zeros get cancelled. 36 ones are, 36 threes are, and 0. So by cross multiplication, we get y multiplied by 1, which is y, equals 30 multiplied by 1, 30. So 30 hours will be required to fill the reservoir. Next problem is, diameter of cylinder A is 7 centimeter, this one, and the height is 14 centimeter, this one. Diameter of cylinder B is 14 centimeter, this one, and height is 7 centimeter, this one. Without doing any calculations, can you suggest whose volume is greater? We observe that the diameter of cylinder A is the height of cylinder B, and the height of cylinder A is the diameter of cylinder B. We will name 7 centimeter as X and 14 centimeter as Y. Now volume of cylinder A, VA, is pi r square, which in this case will be X by 2, which is the radius, square, into height, which is Y. So that will be pi into x square by 4 into y. So that gives us volume of cylinder A equals pi by 4 y multiplied by x square. Similarly, volume of cylinder B, VB, will be pi into r, which is y by 2 whole square, multiplied by height, which is x. So that will be pi multiplied by y square by 4 multiplied by x. That will be pi by 4 x into y square. We observe that quantity y is greater than quantity x. So we write y is greater than x, which implies y square is also greater than x square. Now, in the volume of cylinder B, there is a square of y, and in the volume of cylinder A, there is a square of x. Since y square is greater than x square, we conclude that volume of cylinder B will be greater than volume of cylinder A without doing any calculations. Next, verify it by finding the volumes of both the cylinders. We have to verify this result by finding the volumes of both the cylinders. We will write our first result. Volume of cylinder B is greater than volume of cylinder A. Volume of cylinder B will be pi r square h. So that will be 22 by 7 multiplied by r square, but r is 14, so 14 by 2 will be 7, so it will be 7 multiplied by 7 multiplied by height. The height is also 7, so this 7 gets cancelled, so we get volume of cylinder B equals 1078 cm cube. Volume of cylinder A, VA, will be pi r square h will be 22 by 7 multiplied by r, which is 7 by 2 multiplied by 7 by 2 multiplied by height, which is 14. So this will be 7 ones are 7 twos are 2 ones are 2 ones are 2 ones are 2 elevens are, which equals 539 cm cube. Here we observe that VB, which is 1078 cm cube, is greater than VA, which is 539 cm cube. So therefore our statement VB is greater than VA is verified. In the third question, we have to check whether the cylinder with greater volume also has greater surface area. Surface area of cylinder B, SB, will be 2 pi r into r plus h, that will be 2 into 22 upon 7 multiplied by r, which is 14 upon 2, that will be 7 multiplied by r, which is 7 again, plus height, which is also 7. So this 7 cancels with this 7, and we get 44 multiplied by 14. So that gives us surface area of cylinder B equals 616 cm square. Now let us find surface area of cylinder A, that will be 2 pi r into r plus h, that will be 2 multiplied by 22 upon 7 multiplied by radius, which is 7 upon 2 multiplied by r, which is 7 upon 2, plus its height, which is 14. So here this 2 cancels with this 2, this 7 cancels with this 7, and we get 22 multiplied by 35 upon 2. Here also 2 ones are 2 elevens are. That gives us surface area of cylinder A equals 385 cm square. Here we observe that surface area of cylinder B, which is 616 cm square, is greater than surface area of cylinder A, which is 385 cm square. So we can say that cylinder with greater volume, that is VB, also has greater surface area. So therefore surface area of cylinder B is greater than surface area of cylinder A. Friends, if you like this video, please click the like button. Share this video with your friends and classmates. Don't forget to subscribe this channel to get more videos of this type. Please give constructive comments to help improve my videos. See you in the next video. Until then, keep watching Number Collage. Thank you.